Okay. Good morning, good afternoon, good evening. Ano mang oras nyo pinapanood tong video, yun yung greeting ko sa inyo. Okay. So, we're done with numbers 1 and 2 para sa illustrative problems. Let's proceed to number 3. I think this is the second to the last illustrative problem for this particular chapter. Okay. So number 3. The horizontal pump in the figure below discharges water at 57 cubic meters per hour. Okay, neglecting losses, what power in kilowatts is delivered to the water by the pump? Okay, so this is our schematic diagram. I hope you have your modules with you. Better if you print it so that you can write on it, ano. Okay, so ito yung ating schematic diagram. So we are to solve for the power needed to drive the water to produce 57 cubic meters per hour na discharge. Okay, so we're going to apply the energy equation. First thing we should do is to identify 2 points. So remember, when we apply the energy equation, we always need 2 points, no? Kailangan natin ng 2 points. So saan ilalagay yung dalawang points na yan? As I've mentioned before, we should put those 2 points where we can minimize the number of unknowns in the equation. Minimize natin. So ilalagay natin yung dalawang points dun sa may tapat ng pressure gauges. So at those points, alam natin yung pressure, no? So hindi siya unknown later on dun sa equation. So, and when we identify points, I have also mentioned that we need to follow the direction of the flow. So the direction of the flow ay papunta sa left. So point 1 natin would be dito sa may pressure gauge 1, and then point 2 is dun sa may pressure gauge 2. At those points we know the pressure, so hindi siya unknown later on sa equation. Next is to apply the energy equation, but before that, since the discharge na given ay in terms of cubic meters per hour, we need to convert that to an equivalent discharge in cubic meters per second. Okay, Q is equal to 57 cubic meters per hour. Convert natin sa cubic meters per second. So how many seconds in 1 hour? In 1 hour we have 3,600 seconds. So we have a discharge equivalent to 0.01583 cubic meters per second. Okay, next is we also need to solve for the velocities at those 2 points, since we need those velocities to solve for the velocity head in those points. So with the given discharge, solve natin yung velocities in those designated points. So from the law of continuity of flow, we know that the discharge at pipe 1 is equal to discharge at pipe 2, and that is also equal to the discharge in the entire system. Okay, so if that is the case, we can solve for the velocities at those identified points. Okay, so to solve for velocity 1, diretso na lang natin yung equation para mabilis. The discharge is 0.01583 cubic meters per second. The discharge at pipe 1 is the product of the cross-sectional area at pipe 1 and the velocity at pipe 1. The cross-sectional area at pipe 1 given the diameter at pipe 1, it's equivalent to, so pi times, convert natin yung 9 centimeters to meter. So we have 0.09 meters square all over 4 times velocity 1, yan known. Equal din yan sa discharge sa may pipe 2. So discharge at pipe 2 is the product of the cross-sectional area at pipe 2. So at pipe 2 we have, and the velocity at pipe 2. Diameter at pipe 2 of pipe 2 is 3 centimeters. That is equal to 0.03 meters over 4 times the velocity at pipe 2. So we can solve V1 and V2. So V1 is 2.4883 meters per second, and V2 is 22.3949 meters per second. Obviously, V2 is a lot larger than V1 because the diameter at pipe 2 is smaller, ano? So to produce the same discharge, it should be faster sa may pipe 2. Then we can now apply the energy equation from 1 to 2, since we already know the pressures at pipes 1 at gauges 1 and 2. We also know the velocities at points 1 and 2. Then we can apply the Bernoulli's energy equation. Now in this case we have a pump, no? Ano bang equation natin kapag may pump? So pag meron tayong pump, so pump adds energy in the system. So nasa left side ng equation yung energy head ng pump. So we have V1 squared all over 2G plus P1 over gamma plus Z1 plus yung energy head needed sa may pump was V2 squared all over 2G plus P2 over gamma plus Z2. The problem told us to neglect any loss of energy dun sa system. So we are not going to add head loss at the right side of the equation. And we also can observe from the figure, so the problem tells us that the system is horizontal. That means that points 1 and 2 have the same elevation. So Z1 is equal to Z2. So definitely Z1 and Z2 would be eliminated from the equation. So we're left with V1 squared all over 2G plus P1 over gamma plus HA equals V2 squared all over 2G plus P2 over gamma. So alam naman natin yung V1, V2, we also know P1 and P2, so we're left with one unknown in the entire equation. So let's just substitute the values to the equation. And so what is V1? Hopefully kasha pa yung equation natin. V1 is 2.4883. I will no longer put the units para mas makatipid tayo ng space. G is 9.81 plus P1, the pressure at point 1 or gauge 1 is 120 over unit weight of water. That's 9.81 plus the energy head needed sa pump equals, let me just put it below. That's V2 squared all over 2G. That's 22.3949 squared all over 2 times gravity plus P2. P2 is 400 all over unit weight of water 9.81 kilonewtons per cubic meter. Ayan. So we're left with one unknown in the equation, that is HA. The energy head in the pump is 53.789 meters. Then we compute for the power needed by the pump is equal to Q gamma times the energy head. So the power then is equal to Q in cubic meters per second. That is 0.01583 cubic meters per second times unit weight of water, that's 9.81 kilonewtons per cubic meter, times the needed head. The energy head in the pump is 53.789 meters. So cancel yung cubic meters, we're left with kilonewton meter per second, which is actually kilowatts. So power is 8.353 kilowatts. So that is the needed power dun sa may pump. Okay? So that is the answer for problem number 3. The last problem would be solve na lang in a separate video. Ayan. Separate video na lang. So see you sa next video.